All right. So on Canvas, I put up, let's see if it switches over here for us, your iClicker grade with the lowest 3 drops. This kind of the syllabus stated if this switches over. So that's kind of what reflects all the excused absences, as well as kind of dropping your 3 lowest there. So that's what your final iClicker kind of category grade will be. I'll do a similar thing with the homeworks once I get those all kind of graded. So obviously the individual assignment was due Monday. I should be able to get through all those tomorrow. So you should see a grade kind of pop up in a similar way for your individual assignments. Also, where are they for the connects? And then also for kind of those 4 Excels. Okay. So you'll have kind of what your grade is in each one of those categories. You'll also have your kind of first and second exam score. I then put up this file, which is called Figure Out Your Grade. Download that here. Take a look at it. Maybe. I don't want this here. I'm gonna move this up. All right. So, okay, there we go. You basically like put in whatever your grades are. So like I put in a hypothetical person here. So they got all the iClicker points, individual assignments, Excel, Connect grade, 2 exam scores. You can then play around with, okay, if I'm trying to get an A in this class, right, I get a 90, right, and 95, looks like I'd have to score pretty high to kind of get that A. I don't even know if I can. Let's see. If I ace it, right, it just pushes me over the edge. Right? Now, obviously, like for every single person, it's a different scenario. So you might be thinking about the difference between A's, A minuses, B plus, A minus, things like that. Which it isn't a syllabus, but just to be kind of clear, I can't remember if someone here asked me about it, but I know someone in my other class did. So the cutoffs I use for like minuses and pluses are basically, you can think about for every grade category, although for most of you, this is kind of be the B and the A category. So we've got 80 to like an 82.9999 would be a B minus. Then 83 pushes you up to the kind of B plus, or sorry, not B plus, to a B. 83 all the way up to 86.999, so just below 87, that would be a B, and then 87 or higher is a B plus. So that kind of fits the same category for A's as well, right? So you're kind of looking at that 3 and that 7 to be the kind of cutoff for whatever that next grade would be. Okay. Any questions on any of that? No? You're looking concerned, yeah.
No, I have a question that's not about that.
Oh, okay.
Practice exam A. I just,
okay.
Variables didn't make sense. I didn't see in the Excel where total credit hours were even listed.
Let me see. I might have accidentally put up the wrong file. It's highly
like
possible.
SAT and athlete.
So final exam, this one?
Yeah.
It could be. Suppose. Oh, I did put up the wrong file. What's this one? Oh, this is the Excel document.
Yeah, and it's like GPA, athlete, SAT, and then SAT.
Oh, okay. I'll go back in and look at that. I might have just put up the wrong. So draw the GPA, total credit hours, and then this. Let's see. Download for me. There we go. Oh, so you don't have. So I think if you go to the other sheet, you can work off of that. Yeah, I think this one I pulled out some of the variables to make it easier, I think, for one of the following like further questions. Okay. So you actually have to download it to see that. So if you're just using it on a web browser, it's just whatever worksheet it was open there. Yep. Yeah, no problem. And I'll probably bring in some more problems to kind of work through Friday and on Monday as well. So I may end up putting more files up here, but it would be things that we would look at in class as well, but you would have those to kind of go back on. Any other questions for me before we kind of get going here today? No? Ready for the end of the semester? So We're going to just look at some more examples of linear regression today, maybe a little bit more of application, how we see these things applied to like real world issues. Then on Friday and Monday, we'll revisit some more things that will be very specific to the exam. So I've got the exam a little more than halfway written. It'll be a combination of multiple choice and short answer. So there'll be more short answer than on the previous exam. So I think it'll probably end up being a dozen or so multiple choice, and then like 4, maybe 5, depending if I might break some of the short answer questions I have in mind up into 2 different separate questions. But about 4 or 5 short answer questions with a couple parts to each of them. So the points will kind of be almost evenly split between the 2. It might be something more like 60-40, but it's not going to be as heavily concentrated with the multiple choice points as the previous exams. Because a lot of this is like interpretation. Like I want to see your work, kind of see how you're understanding. Really small mistakes could lead to the wrong answer a lot more with some of this stuff. So a little bit more short answer there. I'll have a little more, exact number of questions on that Monday kind of review session. Maybe even Friday if I'm happy with where it's at. I usually like can't make my mind up about certain questions that I want to leave on or put on. So a little more information about that in future classes. Okay. So I think I put up, so I put up this marijuana legalization and MML and fatalities. But then this morning I kind of changed my mind, and I also want to look at this major choice one. So I'm going to drop that in there for right now. So the first one we'll look at is that MML and fatalities. Okay. So this paper, right, we're going to take a look at some academic papers today and how we see regression applied in real life. And why is this? I'm going to reopen that, I guess. There we go. So there's a lot of kind of more recent research out there on the effect of like legalization of marijuana. So this one was kind of a little bit older data set. And so they were specifically just looking at medical marijuana, right? But you can imagine this would apply to marijuana legalization as well. So what they were going to do is they're trying to pick up a couple things. Okay. So they're going to try to predict traffic fatalities and different measures of alcohol consumption. Right? And they're going to try to predict that using this indicator variable for whether or not medical marijuana was legal in that year, in that state, and 0 if not. Okay. So, and actually they might even, we can check when we're looking at the paper. I can't remember, I thought they did this by state, but they might have even broken this down by county. So you've got the effect of a 1 unit increase in your X variable, but if your X variable is a 1, 0 variable, it's just going from the 0 group to the 1. So the effect of medical marijuana being legalized would change the predicted number of fatalities by whatever our coefficient is, or would change the expected number of kind of drinks, or however we're measuring alcohol consumption, by whatever this coefficient is. And then obviously add in a bunch of additional things that we can control for, like unemployment rate of the state, maybe average income, some of these other things that we looked at in other regressions. Okay. So that's the general idea behind what they're doing. And kind of sneak peek, we'll go all the way down. So this is how I usually read papers. I would look at, where is it? Where's their abstract? Here it is. Read their abstract. So they're kind of saying, okay, we're using state level data, looking at the relationship between medical marijuana and other outcomes. Looks like it's increased marijuana use among adults, but not minors. It also looks like it's decreasing the number of traffic fatalities, and looks like it's having some impact on kind of alcohol use, where it's a decreasing alcohol use, suggesting that marijuana and alcohol are like these substitute goods. So if you go back to like ECON 201, you've got substitute goods, which is like, you use one instead of the other, or complementary, where you use them at the same time. And maybe this varies for individuals. Maybe some people view them more as complementary goods, some as substitutes. But on average, what's that relationship look like? So you read the abstract, and then you go all the way down to look at the tables where the regression output is, because that's where the interesting stuff is. So I'll go down to the last couple tables, because those are the ones I want to focus on first. So here was kind of, they used some survey data about alcohol use and tried to look at, did the number of drinks that someone has in a month on average go up after these medical marijuana laws, or did it go down? And do we see higher or lower levels of binge drinking after these medical marijuana laws are legalized? So if we look here, they've got some other things down here which indicate all these other control variables that they use. So these covariates, that's just another like name for control variables or other independent right-hand side or X variables. So what were those quote unquote covariates? So we'll go back up here. Where was it? They had a list of, here it is. Here's all of their variables that they control for. The unemployment, the income in the state, average income, the average miles driven by people that live in that state, whether or not marijuana has been decriminalized, right? That's a little bit different. Did the state require what? A driver's license where you kind of have like, so sometimes you have to drive for a certain amount of time before you get like your full license. Seatbelt laws, what the blood alcohol content kind of cutoff was. So 0.08, was it 0.08 or higher? Was it something lower than that? What was this? I don't even remember. I don't even know what this is, to be completely honest, but some other control for some other law. They have zero tolerance laws. What was the beer tax, right? In that level, because that would change the price of the substitute good. And then what was the kind of maximum speed limit that state have in that year? So they tried to include all these other controls. And what they found was for these different kind of groups, right? For males, the number of drinks after these medical marijuana laws decreased. So did females. So the interpretation would be going from not having medical marijuana legalized to legalizing it decreases the predicted number of drinks that a male would have by about 1.5 on average, and for females about 0.6. And one thing that academic papers do is they don't show you the p-value, right? So in Excel, or sometimes I'll show you some of the other programs' output, you see the p-value associated with the coefficients. So another way that it's sometimes portrayed, instead of telling you the p-value, they use stars. So 3 stars means that the p-value was less than 0.01, or you have 99% confidence in rejecting that null, which, just to refresh our memory, the null is always what? That slope is equal to 0. So if we have that really, really low p-value, we can reject that, or say we found a significant relationship between these two variables. So 3 stars means you can reject it at that 1% significance level, or you can say that it is different from 0 with 99% confidence. 2 stars, I don't think there's any 2 stars on here, but that would be 95%. And then 1 star is your 90% level. So instead of giving you the p-value, they just kind of indicate what levels they were significant at. Okay. So we've got these, we've got these estimates. It looks like for males and females, the number of drinks goes down. And it looks like females are a little bit less likely to kind of be in this category of binge drinking, although the effect is negative for males as well. We just can't say it's any different from 0. It looks like for older individuals, medical marijuana being legalized, although we do find negative estimates, none of them can we say that they are different from 0. Right? We fail to reject the null. Although for younger individuals, it looks like specifically 20 to 29, the number of drinks, and this isn't significant, but it's definitely the largest estimate we have here for binge drinking. For this age category, 20 to 30, medical marijuana being legalized was really reducing the use of alcohol. More specifically, and they included all those covariates. They also included what we call fixed effects. So I've kind of alluded to this with you guys already, but year fixed effects would mean we're doing something like this. So if I were to just include as a variable what the year was, what that's essentially doing is it's forcing the relationship between the year and, here I'm looking at what, alcohol consumption or whatever it is, that's forcing it to be linear, right? So no matter what the data looks like, right, it's kind of forcing that slope estimate to be linear. When in reality, if I'm looking at different years, maybe one year it's up here, down here, right? Maybe it's like not following a functional form, even though it's changing. So what I can do to capture the fact that it's changing, but not in a linear or even a quadratic way, I can actually just start to go Okay. Include an indicator for if the year was 2020. Include another indicator for if the year was 2019. And then continue to include indicators for every single year, except what else would I have to do? If I break this year variable down into a group of indicators, the interpretation would be this is the expected change in alcohol consumption if the observation or the state in this case was in the year 2020, but relative to what? I've got to leave one of the years out. And what makes the most sense? Probably just leave off the earliest year, right? But I do have to leave one of them out. We call that year fixed effects, right? We're like controlling for the effect in every single year. We could also do the same thing, but do, 1-0 for if it was Indiana, and then a 1-0 for if the observation was in Michigan or whatever. And we can do state fixed effects as well. So they've really like over controlled here, right? They did state and year, and they included all these other variables that we looked at. And they even did some like state specific time trends, which is like picking up that across time, maybe, that the alcohol consumption was changing differently in different states. So we've really got, a lot of strong controls, and we're still seeing that this is a significant relationship, right? That for young individuals, specifically more so males, it's kind of decreasing alcohol consumption. So this would be evidence that these two goods are substitutes, right? When one became legal, right, people substituted away from using alcohol as much. And this plays out in some state level sales data that they got. Now, this is maybe anecdotal, but like this makes sense to me that you would see not much of a change in wine or liquor sales, but really where the decrease in consumption is coming from, the significant result here is beer sales, right? So, and a pretty significant decrease there as well. I think the way that they measured this was in the, does it say here? I'd have to go back. It was like maybe in the thousands or something. The unit wasn't just, one additional dollar of sales. It was like in the thousands. So we found a pretty significant kind of effect here, right? We could say with 99% confidence, because we see 3 stars, that legalizing medical marijuana was decreasing my per capita beer sales by about 0.054. And like I said, we'd have to go back to remind ourselves what the units are on that. I'm not sure if they mentioned that in this table or not. Where was it? Here it is. It's probably in the paper what that units were. You'd have to actually go back and find the paragraph that's referencing this. But we do find a significant decrease, right? So it looks like we have some evidence that these are substitute goods. So then from there, it would follow that, well, maybe if people are using alcohol less, if I believe that impaired driving is any different between alcohol or marijuana, maybe I'd see fewer traffic accidents. And as a result, see fewer traffic fatalities, right? So the next thing we'll look at, I think it starts in table 8. Yeah. No, I want to think it was, up here. Here we go. So here was kind of their first look at, does this legalization impact traffic fatalities? When they didn't include any other controls, they found a pretty strong negative effect. Having medical marijuana legalized decreased the number of fatalities per 100,000 people by 0.248. Now, as they added in year and state fixed effects and the other control variables and these state-specific time trends, it did go down, but it's still significant at the 90% level, and it's still negative, right? So here the idea is it's negative 0.91. I just want to use Excel to show you something kind of interesting. We could start thinking about really what are the impacts of this, or how can we use this result? So we found negative 0.091, right? When we had medical marijuana legalized, that's how many fewer traffic fatalities, deaths we had per 100,000 people. So I don't know, let's just use Indiana as an example. So 6.7 million, right? So if I do what, 670, so 6.7 million divided by 100,000 people. Because remember, the units of this variable is that's the number of fatalities that it saved per 100,000 people, right? So how many 100,000 peoples are there in Indiana, right? Well, I would just divide the number of people in Indiana by 100,000. Oops, I used a comma. There, it got rid of it for me. So 67, right, 100,000 people. So I would basically take my coefficient, that's how many people per 100,000 that are not dying, times how many of those 100,000 people are in my state. And I get that, right? I'm basically saving 6 lives by having this medical marijuana legalized, right? And that's just in Indiana, right? And that's just in 1 year, right? So, I mean, think about if we expounded this, across several different, all the different states. In fact, we could do, well, there's about 330 million people in America. Does that sound right? Divided by 100,000. So we could figure out how many groups of 100,000 we would have in America. Here's the amount per 100,000 that we're saving. So we'd be saving about 300 lives every year. Right? So, it's an interesting result. We're talking about lives here. Like there are individuals who work for huge law firms that do try to come up with the value of lives. But I think a lot of people would argue like this is, this is something that's like difficult to put a price tag on, right? And so just allowing the legalization, we see this reduction in traffic fatalities. Does that make sense what I was doing there? I wouldn't expect you maybe to do something like that to that extent. But sometimes if our variables are in weird units, like this one was per 100,000 people, you're gonna have to do a little bit of like what we call back of the envelope kind of math to figure out exactly what that coefficient would translate to in terms of lives saved. Okay. So that's interesting, right? But they then break it down even further and say, well, look, really, we would expect a stronger effect. It's probably that old effect is being pulled down a little bit by the fact that traffic fatalities that don't involve alcohol use shouldn't change at all. We wouldn't expect them to change by much. So here, right, when they run it only on fatalities where there was no blood alcohol content detected at all, they do not find a significant effect. It is still negative, right? We can't say that that's any different from 0. The p-value is pretty high. You end up calculating the test statistic and looking it up, or looking at the Excel output. The p-value here would be, if I'm looking at this, so this is about 1.34. So we're talking about, well, maybe it's closer than that. It's probably going to be like between 0.15 and 0.2. Right, so it's pretty far away from that threshold. Now, for traffic fatalities where the individual had a blood alcohol content over 0, so just some level, it actually was an even larger effect than we found when we just treated all traffic fatalities the same. And then for fatalities where blood alcohol content was well over the legal limit, right, we see an even greater reduction in the number of traffic fatalities there. So really where this law is having a huge effect is on traffic fatalities that are a result of alcohol consumption, and extremely high alcohol consumption, which fits the other data, which is what we saw consumption going down. Yeah.
Do you know why they would have gotten rid of one observation?
From here?
Yeah.
So it's not that they got rid of one observation. They ended up having similar observations. So this is the number of traffic fatalities that involve no alcohol. Oh yeah, why would they have gotten rid of one? Let's think. Do they say here? Regressions are weighted using the license, clustering state. It would seem like, oh, I'll tell you why. So it's not an easy explanation, but so when you start to include these things like fixed effects, if you don't have any variation, so like let's say I'm guessing this is probably what happened. If you were looking at somewhere like Wyoming, my guess would be that over the time frame they had, potentially once you start to control for the year, you might not have seen any variation in the number of fatalities they had with blood alcohol contents over, above a certain amount, just because every year they only have 1 or 2. So whatever time frame they were using, if there was no variation, what Excel or these other programs would automatically do is say, well, there's no variation in this data, so we have to drop that. So it probably dropped one of the states that, like I said, one of these really small states where maybe they don't even have a traffic fatality with a blood alcohol content over 0.1 some years, right? So my guess is that's where they lost the observation. Yeah. Yep. But yeah, you should always be questioning things like that, right? Like whenever you do see differences, like, well, why did you have a smaller stuff? Because like, let's say instead this was like 900. Well, what 100 of the traffic fatalities are we not looking at? Because those might be driving, some of the results. So good question. And, based off of everything we've included, one thing to point out here is we probably don't need to be as concerned about the omitted variable bias, because if we look at the R squared here, we're explaining like right around 90% of the variation, right? So we've accounted for 90% of the factors that matter, right? What those other 10% are, some of them might not even be measurable, right? Like, but pretty strong results. Excuse me. They then make this a little bit more complicated, but they break it down. So instead of just having an indicator for whether or not medical marijuana was legalized, they then start to include indicators for, has it been legal for 0 to 1 years? Has it been legalized for over 1 up to 2 years? And these are all indicator or dummy variables, right? So now we've just got different lengths of time, right? So now it's like interpreting our coefficient would be, if medical marijuana has been legalized for less than a year, this is the predicted change in traffic fatalities. If it's been legalized for 1 to 2 years, this is the expected change. And I think the group they left out here was they also went back in time. So I think the group they left out was any observation that was more than 3 years before that law change. Right? So to kind of notice here, in the years before the law change, hopefully we don't see anything significant. This is almost what we call like a falsification test, right? These coefficients, they should be 0. It wasn't legalized yet, right? So we look here and none of them show up as significant, right? Some of them start to get kind of negative as we get closer to that year where the law is going to change. Maybe some of this is being driven by some early adopters or something like that, where they expect that it's now going to be legal in the following year. The year of the change, we wouldn't expect to see too much, right? This is like a lot of these places, it may not be enacted until halfway through the year, right? And so maybe we don't pick up any effect there. But then as soon as we start to move from 0 to 1, 1 to 2, 2 to 3, or 3+ years after that law change, you can see that the longer the law change is in place, the stronger the impacts here. So now we've got like negative 0.28, right? So if we do our little back of the envelope here, now we've got a much higher estimate. Now we're thinking about, we're almost getting close to saving 1,000 lives from these high blood alcohol content accidents that are happening. Oh, that's not what I wanted to do. There we go, right? From high blood alcohol content levels. Okay. So it's pretty interesting. Like most of this is being driven by, once this law has been enacted for several years, then we really start to see people changing or substituting their consumption over to marijuana. Right. Any questions on this before we keep moving here? So pretty interesting results. This is kind of, I always thought this was like a funny part of it. But there's not the greatest differences, but there are stronger results that this reduction in traffic fatality is happening on the weekend and at night, as opposed to weekdays during the day. I mean, this I think is intuitive, kind of makes sense. Like these high blood alcohol content, like you're seeing most traffic fatalities on the weekend at night, as opposed to, well, hopefully, you don't have someone during the day on a Wednesday, like driving around with a 0.15 blood alcohol content, right? Just less likely. So really a lot of these results are being driven by fatalities that are no longer occurring on the weekend and at night. And I think they break it down by age groups. You can kind of, as you would expect, there's a negative effect across all age groups, but it's really being driven by kind of your younger age groups, right? 20 to 29 and then 30 to 39. And then not significant for the higher groups. So we keep going down. A little bit stronger impact on males than females here, right? We see a little slightly higher coefficient. So, you know, for whatever reason, there looks like there might be some differences across gender in terms of how much of a substitute this is. But no, I don't know. I thought this is, I remember I found this one, really interesting results. It's a very simple, like this regression is pretty simple. Like, it was just a 1-0 indicator. We threw a bunch of other stuff at it and, you know, other data that they had and got a pretty strong result. So, you know, this shows you like using these regression tools, like this allows to predict, like if I'm a policymaker, a politician here, I'm like, yeah, you can literally save lives. Like, as far as I know, I don't know what the number of accidents because of marijuana use is, but my guess is it's way less than 1,000 people a year would die from a marijuana related accident. Like, I'm sure it happens, right? In terms of like a non-traffic related act, but you know, I think as a policymaker, this is pretty strong, a strong argument to like, yeah, you can definitely decrease alcohol consumption, which we know has some negative impacts on individuals' health, as well as decrease the number of people who are dying from these traffic fatalities. Any questions for me on any of this? All right, so we're going to go to a next level paper that I won't expect you to necessarily do. I think this was the one I dropped in there, which was major choice. So I'll explain to you kind of what they did. So this paper, and I forget the details, we can look at it in a second of exactly what the letter said, but they had two universities, Montana and Montana State, and all this data on the students there, right? And what they started to do was they wanted to make students aware of the debt that they were going through. So they started sending these students who were taking out above a certain amount of money letters about how long, given their current major and that major's average salary, how long it would take them to pay it off. Like, just making them aware, right? And so you've got two, but they only did it at one university. So they kind of used, I think, Montana as the control group, right? And they identified different types of students who would have been qualified to receive this letter, but they didn't actually send them the letter, right? And then at Montana State, they had the similar sort of identified the people who met the qualifications to get this letter, but they actually sent the letter to them. So now it's like you have these two otherwise like identical kind of groups of students. One of them got the letter though, and one of them didn't. So who got the letter? Well, you had to be at Montana State. So we're thinking about the coefficient they're looking at here was you had to be at Montana State. You had to be eligible to receive the letter. And then they went a step further and they got data on these students who were eligible for the letter, but they had data before and after they actually received it. So they then called this, was the observation in a time period post actually receiving the letter. And they included, I should actually call this like, so I'm thinking about here, they've got different Y variables. So they included, was this at Montana State? They included an indicator for, was I eligible to send the letter? So they included all the different kind of combinations of these things. But here, we'll call this, I think they call it beta 5. We'll call the combination of those three things. This is where I should be picking up the effect of, was I at the university that was sending out the letters? Was I eligible to get the letter? And was it in a time period after the letter was sent? So this coefficient should tell me the impact that this letter had on different choices by the student. And we're controlling for the fact that, like, maybe there was additional effects of just being at Montana State. Maybe there's additional effects of being eligible to receive the letter. The combination of being at Montana State and being eligible to receive the letter. All that's being controlled for. And this like triple interaction term, what we call this kind of strategy where I've got my control group, Montana, and then I have my other group, Montana State. I have both of them in a before and after time period. That's where that kind of post variable is coming in. And then I have different students who either receive a letter or don't at both. So I've got like this huge control group built in. And what we call this is difference in differences. So we'll look at students at Montana State who are eligible to receive the letter in a time period after they could have been sent the letter. Sorry, I said that wrong. We're going to look at students at Montana. That's where they didn't get the letter, right? We're going to look at them, the difference between the students who were eligible to receive the letter at Montana before and after they would have been sent the letter if Montana was also participating. So we're kind of picking up, well, maybe there was just changes over time, right? So we're able to kind of see what those changes over time were for students who were eligible to receive the letter but didn't at this university. And the other university, we're going to take students who were eligible to receive the letter in the before and after, but they actually received it. So the differences in those changes between those two time periods will really tell us what this causal effect of sending the letter out to the student was. So I would never push you guys that far. This is kind of next level where I said, I think I mentioned last class even, these results are great, but we have to go a step further to get these causal relationships. Doing this difference in difference allows us to say it's a causal relationship. So kind of, we'll go through down here, look at some of their results. So here was their regression, right? They included all this stuff. The post time period was 2012 or after, and they looked at different kind of outcomes for the student. So, and like I said, all this was like making the student aware, if I remember right. Where they actually talk about the letter? Yeah, if you continue to accept loans at this rate, it's going to be difficult to pay off. Like you might want to reconsider. So just making them aware that they're taking out an amount of loans that's really going to be hard to pay off. So here, oh, sorry, it wasn't beta 5. It was beta 4 on that triple interaction. They then basically ran a regression. So each one of these kind of columns and each one of these, like, I guess, bold headings represent different regressions. So they ran a regression where the Y variable was, did the student change their major, right? So they ran this regression that they had up here where the Y variable was, did the student change their major after receiving this letter? Okay. What they find was, after receiving the letter, the probability that a student changed their major went up by about 2%, right? The probability went up by 0.02, so about 2% more likely to change their major. They then said, okay, did they change, what was the change in the probability that they changed their major to business? Probability they changed their major to education, right? Ran additional regressions for different types of majors. And the interesting thing is here, you can kind of see people were less likely to switch into a health major and more likely to switch into kind of this business major, right? And maybe this is the idea that making them known, like your current major, this is going to take a very long, it's going to be very difficult to pay off your student loans, might have influenced some people to change their major. Right? Even more so, right? You can kind of expect, well, okay, but if you send this letter out to a junior or a senior, how can they change their major at that point? They have to stay longer. So there's just like additional cost. So maybe this effect is being driven by primarily freshmen. So they actually looked at just freshmen and found, yeah, that's where the strongest impact is, right? If these freshmen are sent this letter after taking out this amount of loans that like push them into being eligible to receive the letter, they'd be 3.6% more likely to change their major to business and 3.8% less likely to kind of switch into or kind of remain in a major that's in liberal arts, right? Or switch into a liberal arts major. And they're more likely to switch into science as well. So, excuse me, kind of an interesting result there. They then kind of broke this down and said, well, look, if I have high quality students, they don't care what their major choice is. They believe that they're going to be able to, rise to the top maybe. So when they looked at students with higher GPAs, a lot of these effects kind of go away. There's still a negative effect here for being less likely to major in health, but it's not real strong. You can kind of see here, the people who are like making more movements are going to be your lower quality students, right? And then they did the combination of being a freshman with lower high quality. And you really see the results are kind of being driven by these lower GPA kind of freshmen is where we see some of our strong results. Although the high end for the sciences, they were really way more likely to join kind of a science major for some reason. But this letter was having an impact, right? It is changing student choices. Okay? So the next thing I think I had, so that was kind of an interesting result. But I also had a paper, it was the exact same setup. Since we have a little bit of time, I'll kind of show you. But all they did, right? So they have that same triple interaction. All they did was look at different outcomes for Y, right? So not just major choice, but did the amount of loans they take out after receiving this letter change at all? So looks like the amount of loans they took out was actually went down. I forget the units of how they measured this, but we're kind of looking at just for significance in the sign, just for the sake of like the discussion of what was happening. So after receiving this letter, they took out smaller loans. Sorry, they took out fewer loans. The amount of the loan they took out was more likely to decrease, right? So this was the probability they took out a smaller amount of loans the next year. Excuse me. The interesting thing is here, their GPA also increased as well. So maybe when being made real, like, aware that, yeah, unless you get a good paying job, like you're going to be paying these loans off for a while, it looks like it incentivized some students to work a little bit harder, right? And then kind of similar to the other one we already saw, they were more likely to choose a STEM major, right? Kind of math, science, business. And a little bit more likely to take more credits, although it was not significant, right? It was positive, but not significant. So this, I mean, like I said, this letter was very basic. Like it was not that detailed, and it was started to alter kind of student choices. They then break it down on only freshmen, right? So they're only looking at the effect on freshmen. And there, if we kind of compare, the effects are kind of the same size, but they're larger than what they were up here, right? So we see stronger effects on freshmen, which makes more sense, right? They have more flexibility in like changing their path. And so, all the same sort of things. They were less likely to take out a loan, more likely to take out a smaller amount of loans, more likely to switch into a STEM major. And here, even though it's not significant, it rose in size quite a bit, the number of additional credits that those students decided to take. And we keep going, we'll break it down even further. When they looked at only freshmen, and I think here, what did they do? Oh, they started to include additional controls, which were like the aid the students are receiving. So like for a subset of their data, they had some information about the FAFSA information for their students. So when they could use those controls for like need-based, like maybe some people like, yeah, you couldn't take out a lower loan amount because you didn't have any additional aid. Like you weren't just taking it out. I had a roommate once. This blows my mind. And it blew my mind at the time. I remember he came like back to the apartment one day and was like really happy. He was like, yeah, I was like, what's going on? He's like, well, they just increased the amount of loans I could take out by $5,000. So I got another $5,000. He wasn't using it to pay for school at all. He just literally wanted $5,000 to blow while he was in college, right? So some people have that luxury, other people don't, right? And so controlling for that aspect, maybe we get some different effects. So once they controlled for that, what they found was for freshmen, actually for everyone, but strongest effects for freshmen, they were increasing their GPA even more, and the number of credits they took each semester went up, right? So, this was having real impacts on the students at this university. I don't think there's anything interesting down here. They did some other stuff. It's not, there's nothing much. That's a lot more interesting. That was kind of the last kind of thing I wanted to mention. Once they kind of controlled for that need-based financial aid, what they found was students who received this letter who had the ability, right, to alter their loan amount, those were the ones that they're really kind of impacting them, taking higher number of credits, increasing their GPA, more likely to switch into these higher paying STEM majors, and less likely to take out as high of loan amounts. Yeah.
I don't know if you already said that, but what's the plus sign?
Oh, they had something. So this is very close to significant. So this is like, they agree with me. A lot of people wouldn't have put that in there. But if you figure out what this p-value is, it's going to be very just on the other side of 0.1. It's just barely not significant. And so I think they probably threw in a footnote down here. Plus sign. So they said that it's less than 0.1, which so they couldn't reject, but they're like indicating that it was really close. Like, yeah, the p-value wasn't quite less than 0.1, but it's like really, really close. Actually, no, sorry, I lied to you. It is 0.1. They actually just use a slightly different notation here. So they wanted to really indicate if it was highly significant, if the p-value was less than 0.001. So they set like an even harder benchmark. So that plus sign for them was just 0.1. That's not very common. For the majority of papers you would look at, they use that 3, 2, 1 star system. I don't know why. I guess they may really wanted to make a point that some of these things were highly significant. Yeah. Any other questions for me here? So hopefully like these are interesting. You can start to see like what you can do with regression analysis. I mean, I just applied this to, policies, right, that existed, like medical marijuana. You can look at like within universities or within companies, different things that they do. They could pick up the effects of those. But yeah, well, I don't have to like preach to you guys because you're all in the business school, so you'll be okay. But I always think that this is a good example. I think that since they're all public institutions, they should have to like provide you with like a table or a database where you could put in the amount of the tuition at that university. You could then put in your major choice. It would use like the average salary, and then like tell you how many years it would take you to pay off the tuition at that university. That would be like a great like tool / project that I don't have time to do. But it'd be interesting to see like if a letter changes people's decisions, right? Like putting the actual numbers in front of them, I gotta imagine would really have some sizable effects. So. All right, so hopefully these are kind of, I guess, fun topics, kind of show you the power of what we can do with regression. We will do primarily just kind of focus on review on Friday and Monday. So if you have a chance, if you take a look at those practice exams, bring any questions that you have so that I can make sure that we're kind of working through material that you have the most difficulty with. And other than that, I'll see you guys on Friday.